1555, March 30th, 2026, right now marks 2,259 hours of progress on the global heart simulation. Currently, some interesting behavior has been witnessed within the program that indicates that a different solution is necessary to solve the issue of calculating a accurate vision cone for a voxel grid. And the idea most recently was to create a grid of rays and then subdivide those rays into points across their length, and then check the closest voxel to each point and determine which point on each ray is closest to the origin, and then all points behind the blocked point are then tagged as blocked as well. But that idea seems to not be feasible, as while testing the code that calculates points along the distance of a ray, it's noticed that as rays get further from the distance, the amount of misses of voxels would increase as there would be gaps between the voxels. So the intention going forward is to look toward creating a different sort of algorithm that would handle voxel line of sight differently, as currently it is already noticeable that the current approach would not work, as besides there being gaps between voxels at a distance, there's also the issue of the closer a voxel is to the origin of the rays, or the eye, there's a wasted calculation that there's multiple rays intersecting that individual voxel. So the intention going forward is to look into creating a different sort of algorithm, perhaps a tree structure, where voxels have a parent and child relationship, and as a parent is determined to be blocked, the child is also blocked. And the major complication would seem to be resolving how to come up with the parent-child relationship in the first place, and also have it work as the eye rotates, as the voxels seen should also be different depending on the rotation of the eye. So the intention going forward is to figure that out in order to create a vision cone system that works in 3D space using voxels for calculating the line of sight.